last portion of lecture 3. Um, when in the software, especially the efforts that people are doing to make the interfacing software to be a generic one so that any kind of CAD model can be incorporated into this interfacing software and create the tool path for the deposition process. So in order to do that, you have to um, have several steps taken by the interfacing software in order to get the tool pathways. But this is not very accurate, nor it is very easy, but it is being done by a number of different groups. And I mean, any mistakes that the interfacing software or you discover in that, you have to have a correction software which things like Magics can do. So, anyway, what it does is it creates all these tangents so that when you when the deposition head moves from one point to the other to the next, so the time it takes to make this component, whole component, for example, if this is the perimeter line for your particular layer, the depositant head has to go here, deposit enough material and solidify, and then move to the next one. So the time it takes to build this particular part is dependent on how long, how many segments you have on that particular line and how close you are. So the closer you are, the more time it takes for your machine to make the part. And it is also based on how, I mean, suppose for example, if it is a circular perimeter, you are probably not going to get the ability to make it exactly circular. So it's going to be like, this will be a straight line, this will be a straight line, this will be a straight line, this will be a straight line. So you are going to have some kind of a uh, not a perfectly circular type of a component, especially if that is a perimeter. Now, how close your interfacing software can make this close to what you have in the design is going to determine how accurate your final component is going to be. Okay, so these are some of the steps that the interfacing software has to take. And you have to, I mean, these are some of the steps that, again, in order to make this, those triangles all fit properly together. And anyway, I mean, this is probably a lot more information than you want to learn, but just understand that these are the kinds of things that need to be done in order for us to take this technology forward and to make it possible to make functional components. For example, and this becomes even more difficult if you have multiple materials. Say, for example, if you have multiple alloy systems, or you have one component and you have a coating on top. I mean, this is just an example. So you have to have the deposition head come and deposit this material, then it has to move away completely, and the next one has to come in and deposit the next set of materials. And how smooth and how close it is to the final design part is going to determine how well your technology is going to be adapted and adopted by the manufacturing industry. So you also can have graded materials. For example, if you start with one material and you grade that, this is just an example of just colors. For example, if you are making a gear, okay, or if you are making a turbine blade, and you want to put in one type of material in one position, and then you want to have, say for example, an oxidation protection coating on top. Do you want to do this separately, or do you want to do this as part of your additive manufacturing process? Well, if I were the manufacturing engineer, I would like that to be part of the manufacturing process itself. So these kinds of changes, color changes or material changes, are going to be commonplace in the future. Or for example, you can have one type of material laid down, and then your head comes in and he treats this position so that it hardens that position, so that it becomes a wear resistant surface. For example, the inside is not going to be wear resistant, it is going to be tough, but the outer area could be hard and wear resistant. So these are again how your microstructure is going to be controlled over the entire component. So you have to introduce all that information into your interfacing and layer wise information. So you can have a certain texture map already incorporated in one particular position, location of your computer, and this software, while it is being built, while it is building the component, it can go there and look it up. Now, it can't take 2 hours to lay down a part that should only take 5 minutes. So you have to have really fast computers going and doing these things, and then bringing that information and incorporating that into your build parameters. So there are multiple things that you have to incorporate, and each of them has to have certain operators, and you have to define those operators ahead of time to the interfacing software so that it knows where and what to go and look for. So the material properties can be named by name or by physical property. So suppose it knows that this material has to have 65 RC. It knows that it has to be martensite. So it knows that you lay down this particular steel with a particular carbon content, or you add alloying elements to it to get the right kind of hardness and microstructure. So these are some of the different parameters that you need to introduce into your interfacing software. Anyway, that's all for lecture 3, and I will start the next lecture for the next class.